So now we can learn how to draw two-dimensional graphics. What we're going to learn is how to set up a two-dimensional drawing canvas and then how to draw things in it. And we're going to learn how to do this using the Scalable Vector Graphics specification for two-dimensional graphics. The Scalable Vector Graphics specification is a method for describing two-dimensional graphics for a variety of systems. One of the systems that it works with is HTML, so you can embed two-dimensional graphics in a web page by putting an SVG tag in your HTML code for the web page. And this is an example SVG tag. It has a width, a height, and a view box. The width and the height describe the width and height, usually in pixels, of how the graphics will appear in your web page. The view box describes the coordinates that you'll be drawing with. And so these are your canvas coordinates. It'll start with an X and Y coordinate, and the canvas will extend to the point X plus W, Y plus H, so it'll have a width and height of W and H units for drawing. And so the important thing to remember for SVG is that this origin, this X and Y, is the upper left corner and not the lower left corner in my previous example. SVG, particularly when it's being used for a web page, is being used to describe a document system, and we tend to read left to right, top to bottom, and the coordinate system is set up appropriately. The other thing to remember is that when we set up this view box, we're setting up our canvas coordinate system. These are the coordinates we're going to be drawing with, and when we describe the width and the height of the SVG tag, that's describing the actual display pixels of the result. And so we're automatically getting a canvas to screen transformation between these two coordinate systems. So here's an example of that plot of a parabola, y equals x squared, using SVG graphing coordinates. Here's our SVG tag. We'll set up some width and height for some number of pixels depending on our output device, but we set up a view box that's going to give us the coordinates, the canvas coordinates that we're going to use to draw the graph. And so we'll set them up coordinate systems going from 0, 0 to 1, 1 for canvas coordinates to draw in, and we'll draw the axis, title, and other decorations. Then we can set up another canvas with another SVG tag, and so one of the elements of the Scalable Vector Graphics specification is another Scalable Vector Graphics canvas. And in this case, we're going to put the canvas at a point 10% in. Since our original canvas goes from 0 to 1, 10% would be 0.1 units. So we'd have a point 0.1, 0.1 here. That's the XY coordinate of the upper left corner of our canvas, our blue canvas. And it's going to have a width of 80%. That'll be 80% of the original drawing coordinates. So it'll go from 0.1, 0.1 to 0.9, 0.9, and its width will be 0.8 units and its height will be 0.8 units. And so I can set this canvas up, this sub-canvas up, and I can set its own canvas coordinate systems. So this is the coordinates that's going to be displayed in the outer coordinate system, and then these are the inner coordinates, the blue coordinates that we're going to use to draw things in this blue coordinate system. So its canvas coordinates extend from 0, 0 to 1, 1, 0, 0 to 0 plus 1, 0 plus 1. So then we can plot the data. In this case, since we're starting at the lower left system, we have to plot it as x comma 1 minus y, but we can use a coordinate system where we don't need to rescale things inside this inner coordinates. When we plot data here, it goes through a coordinate transformation to figure out where the point is in the yellow coordinate system, and then it goes through another coordinate transformation to get out of the yellow canvas coordinates into the display coordinates defined by your width and height. So there's several coordinate system transformations that are happening, but we're setting up coordinate systems to make it more convenient for us to draw and letting the computer take care of all the transformations. As before, we're going to draw primitives by specifying vertices, and then we're going to connect those vertices with either straight lines or smooth paths. Those are called strokes. And then we can fill in regions with fills, and we can specify various properties for fills and strokes and so on. And so we can go through the different drawing primitives available to us in the scalable vector graphics specification. A very simple one is a circle. So if I've set my canvas coordinates to go from 0, 0 to 1, 1, I can specify a circle by specifying its center at the point CX, CY in canvas coordinates, in this case 1/2, 1/2, and I can set its radius to be 4/10 of a unit. Since 5/10 of the unit would get me to the edge, it leaves about 1/10 of a unit there. I can set a property of the stroke to be the color black, and I can set the property of its fill to be the color blue, and I get a black circle with a blue interior as a result, and that will be embedded, in this case, in my web page. You can also specify a rectangle, and this is going to be another useful data visualization tool. Again, we set up a canvas, a drawing canvas, and then I say rect, and I specify a point. In this case, 0.3, 0.2 gives me a single point, and then I specify the width and the height of the rectangle, and this point I've specified will be the upper left point of the rectangle, and then I say that I want the lines, the strokes of the rectangle to be black, and I want it to be filled with a blue color, and I get this resulting rectangle. You can also specify paths. In this case, I've specified a path by specifying a bunch of points, 0.2, 0.1, 0.2, 0.3, 0.4, 0.3 through here, and then I've specified a bunch of commands, and these commands are move to the point 0.2, 0.1, so move without drawing a line, and then move while drawing a line from 0.2, 0.1 to 0.2, 0.3. And that way I can specify a line by starting here and ending here and at 0.2, 0.3, and I can specify the next line by starting at the current position and moving to a new position, 0.4, 0.3. So these M's mean move from the previous position to a new position without drawing a line, and these L's mean move from a position to a new position while drawing a line. This way I don't need to, if I'm drawing a continuous line from one point through several other points, I don't need to re-specify these points. I don't need to say draw a line from here to here and then from here to here and specify this point twice. I can specify this point once and say just draw a point to here from the previous point, which is the endpoint of the previous line. And so this will draw what I wanted to be a block eye, but I'm missing this top part. And this is part of the path specification. So I'm drawing a path, and this is D is the data for the path. If I want to get this missing line at the top, I just need to add a Z at the bottom. And this Z just says close the path. That means draw one last line from the last point I specified to the first point I specified. And that will close the path. And then I can fill in that closed path by just specifying a fill specification. In this case, I didn't say stroke equals black because it may have been set up before that way, but that would give you a black outline of a blue region. So what did we learn? We learned how to use the scalable vector graphics specification to make our own line art for web pages. We figured out how to set up an SVG drawing canvas, which has its origin specification in the upper left corner instead of the lower left corner. And then we figured out how to draw a circle, a rectangle, and any polygonal shape.